This video will cover the operation of the air brake solution and how to use it. Let's go through the controls and instruments first. Here is the pressure regulator. It's a piston type, so it's very rugged. It's limited to a maximum output pressure of 120 psi, so you can't accidentally overpressure the air brake system. The pressure regulator allows us to set the target pressure where we want to do our testing. This is the target pressure gauge. When we set the pressure regulator, the setting is indicated by the target pressure gauge. We're already hooked into our test tank, so we'll set it at 100 psi now. Reset valve. To speed up the fill process, the air brake solution bypasses the two flow meters for about 90% of the fill process. We need to evacuate the air switching circuit to bypass them. Simply cycling the reset valve, like this, does that. This is the lock and load lever. It's in the lock position here, allowing us to set the target pressure first. Then we move it into the load position. Airflow into the brake system begins. Target pressure drops at this point. Don't try to reset it. The system pressure gauge. The pressure building in the air brake system will be reflected by the system pressure gauge. The airflow meters. We'll discuss the airflow meters while we're filling the system. The low flow meter measures from 0 to 0.2 liters per minute. Any leak in this area is very small indeed. You'll be using this meter more after a repair than before to evaluate your results. The high flow meter is where you'll be looking for your initial results before a repair. This meter measures from 0 to 3 liters per minute. As you can see, system pressure is rising, and the airflow meters are not engaged at this point. Airflow is approximately 150 liters per minute into the air brake system when bypassing the flow meters. As system pressure rises above 90 psi, the airflow circuits are automatically shifted to go through the airflow meters. At this point, airflow is reduced to about 50 liters per minute, as the airflow meters restrict the flow. At 50 liters per minute, the airflow meter's indicator balls are pinned high, well out of range. System pressure continues to rise, closer to our target pressure. As they get closer to filling the system, airflow begins to slow down. When the flow slows down to 3 liters per minute, the high flow meter ball will begin to drop into range. Here, the airflow meter ball begins to drop as airflow continues to slow down. We're looking for 2 or 3 stops that we refer to as stable readings if they last for 15 seconds or more. It has stopped at about 2.4 liters per minute. We'll time this stop, as it could be the size of the leak. At this point, the ball has dropped to 2 liters per minute. We will continue to monitor it. After 2 minutes, the ball is dropping again. Here it has stopped at 0.6 liters per minute, and we've been timing it for a while, approaching 3 minutes. This will be the final stable reading, where the pressures have equalized and the flow appears lower since everything is equalized and settled. This final 0.6 value is always smaller than the actual total leakage. The previous 2 liter per minute value is the size of the total leakage. Since we can't hear a leak, we know we're dealing with at least 3 small leaks. On a perfectly tight system, both flow balls will drop to 0. and look like this. This has been an abbreviated look at the Airbrake Solutions leak measuring process. There's more information on our website and in the user's manual. Thanks for watching. We'll be posting more videos as our users send them in.